This video is going to get you ready for the very beginning of Chapter 6 when you go to take both your quiz and your test. So kind of walking through that very first day of material, which we called 6.2, which was a lot of looking at polynomials, what makes a polynomial, what doesn't, and then 6.4, which was a review of factoring and solving. So the first thing I want to make sure you understand in order to be successful on the quiz is what is a polynomial and what is not. And a lot of times the easiest way to explain that is just give a lot of examples of what to look for that makes something not a polynomial. And we discuss a lot of these in class. What you're looking for is if you have an exponent that is a variable. So if you have 3 to the x power, that is not a polynomial. If you have a radical around a variable, so like a square root of x, that would constitute not a polynomial. Now it's okay to have a square root around a number. You can have the square root of 2, but you cannot have the square root of x and still maintain as being a polynomial. You cannot have a power that is negative. You also cannot have a power that is a fraction. So all of these things are things you're looking for when we're talking about is it or isn't a function. You're looking for these issues. Polynomials should have powers that are all numeric, they are all positive, and they are all whole numbers. So you're going to see things like x cubed, x squared, x to the fourth, x, or constant values. Anytime we throw something else in the mix, it's not a polynomial. So you should be able to identify things that are and aren't, and you should be able to explain or just show why something isn't a polynomial. What's the issue? What kind of breaks the rules of being a polynomial? The next thing you should be able to do to be successful is I should be able to give you functions that are polynomials and ask a series of questions about them. The first question usually is get it in standard form, and standard form is helpful for a lot of reasons. Once it's in standard form, we can really start answering a lot of questions about it, so you want to start with that first. So I have SF standing for standard form. What I want to do is rearrange my terms so that I have the highest degree first and then the next highest all the way down to the constant term if you have one. So for this one, the highest term is this last term. Make sure you bring the negative 1/2. That's its coefficient with it. So you have negative 1/2 x cubed. The next term is going to be the x squared one. So you have a negative 6x squared. And then your last term is going to be your constant term. You don't have to have every descending power, like this one doesn't have an x term. So if you don't have that, you just skip on to the next one. And remember that the sign that is in front of it is attached to it. It goes with it. The next thing you're asked for is leading coefficient, which a lot of times you'll see as LC. Leading coefficient means the very first coefficient once it's in standard form. So in this case, it is negative 1/2. If you have nothing written there, keep in mind that's like a 1. So if you just have an x cubed, that is a 1 as your leading coefficient. Your degree is your highest power, so this would be degree 3. And then the type comes from the degree. We had different types that we had to learn. If it doesn't have an x, we call it a constant. If it has just x to the first power, that is linear because it forms a line. If we have x squared, that's called a quadratic. If we have an x cubed like this one, that is called a cubic. And if we have an x to the fourth, that is called a quartic. So those are the types that you should be able to recognize and then write down. This one is a cubic because it's a third power. One of the last things that we did in that opening section was we talked about how we use something called synthetic substitution to figure out what happens when I plug different numbers in for x. And this was comparing it to direct substitution. Direct substitution means you just plug it in directly, whether you do it by hand, whether you do it using your calculator. Synthetic substitution requires you to have the box of the coefficients. It is important to put zeros if you're missing any of the terms as you go down in decreasing order. So for example, this one does not have a cube, so I do have to put a 0 there. I have 2x squareds, negative 8x, and 1. And the number outside of the box is the number that I'm trying to plug in for x. We drop down the first number, multiply, add, multiply, add, multiply, add, multiply, add. When you do synthetic substitution, unlike synthetic division, the only thing that's important here is this last number. This is the value you get when you plug negative 2 in directly. So you can write your answers a couple ways. You can say when you put negative 2 in, you get 9 out. That's the point that's associated with it. You can also just say that y equals 9, meaning when I plug negative 2 in, I get an answer, a function value of 9. If you want to check your work on something like this, you could plug it in directly. Please be careful with parentheses. You will have to keep parentheses around this the whole time. Plug it into your function and make sure you get the same value. This is a little different from synthetic division because in synthetic division, when you divide, all of your numbers that you're left with have a meaning. It's telling you how many x's or how many x squared you have, and that last number is your remainder. When you're doing synthetic substitution, all we care about is that last number that tells you the value you get for y when you plug in that number for x. The last piece is a review, looking at all the factoring types we've done since the beginning of the year. With these, you should be able to factor them completely, doing as many factoring techniques as possible, and then tell every solution you can find, whether it's a real or imaginary solution. So when you do these, first thing you want to do is make sure it's in standard form. Next thing you want to do is see if you can take out a GCF. So this one you can take out an x, which leaves you with an x to the fourth minus 4x to the second minus 21. And then you want to see if you can factor it further. So this is a FOIL factor. So we're going to break down into x squared times x squared. It is going to be 1 plus and 1 minus. To get 21, it could be 7 times 3. I want 7 to be negative and 3 to be positive. You can do a quick check of FOIL to make sure that factors correctly. It will not factor any further, so you're done with the factoring, but now you have to go through and find the solutions. So you want to look at each factor and see what makes that factor equal to 0. So we'll start with the x we have out front. What would make that 0 is just the number 0. Then we'll look at the x squared plus 3. It might help to go off to the side and write x squared plus 3. What makes that equal to 0? Subtract 3 from both sides, so we get x squared equals negative 3. Take the square root of both sides. We end up getting plus or minus I radical 3. And then what makes x squared minus 7 equal to 0? Again, you can come off to the side to do a little work. Add 7 to both sides, so you get x squared equals 7. Take the square root of both sides. This time we don't have to worry about an imaginary, and 7 does not simplify, so we get plus or minus the square root of 7. We talked a lot about how the degree is going to help us figure out how many solutions we should be looking for. This one has a 5th degree, and you'll notice that we have 1, 2, 3, 4, 5 solutions. 2 of them are imaginary, 3 of them are real. The last factoring one, again, go through, make sure it's in standard form, which it already is. See if you can take out a GCF, which you can't. There is nothing to take out. It's only 2 terms, and they are perfect cubes. So this is a perfect cube factoring, which it does help to write down your a and b value. Your a value is what was cubed to get 27x cubed. That's 3x. Your b value is what was cubed to get 1, which is 1. The formula is a minus b, so 3x minus 1. Times a squared, so square 3 in the x, you get 9x squared, plus a times b, which is 3x times 1, which is just 3x, plus b squared, which is 1 squared, which is 1. Now I'm looking for solutions. This will never factor further. That's the nice thing about the perfect cube formula. You will not go another step. Even though you have that trinomial, it will not factor. I want to know what makes 3x minus 1 equal to 0. So 3x minus 1 equals 0. 3x equals 1. So x equals 1/3. This piece, when you're doing a perfect cube factoring, not only will it not FOIL factor, it also will not give you any real solutions. So to find the solutions for this one, your only option is to use the quadratic formula. So I'm going to write below it a, b, and c. And my a value is 9, my b value is 3, my c value is 1. So my formula is the opposite of b, plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. I'm going to go through and simplify. I'm going to figure out what the discriminant is. So I have 9 minus 4 times 9 times 1. I actually do not need parentheses for that. So 9 minus 4 times 9 times 1. I get a discriminant of negative 27. So I have negative 3 plus or minus the square root of negative 27 over 18. I could simplify that even more and break that down into 9 times 3. So I get negative 3 plus or minus 3i radical 3 over 18. Some other things you could do, if you're looking for a decimal answer, you could plug this in your calculator, making sure the numerator is in parentheses. It will give you imaginary answers as a decimal. Another thing you can do is you can reduce this square root. You can simplify it. So you can take negative 3 divided by 18 and then the 3i divided by 18. So there are a lot of options for what you could do to simplify this. But the biggest thing is that you went through the process of the quadratic formula and found these solutions, and you should expect that they are imaginary. With your perfect cube function, this piece piece will always give you one real solution. This piece will always give you two imaginary. And the imaginary are the ones that take a little bit of work because you have to go through the quadratic formula and you don't have any other factoring options for you. So that gives you a little bit of an idea of review. Obviously, the factoring techniques, I didn't take the time to do a grouping one, so you should be able to do grouping factoring. You should be able to do difference of perfect squares. What I mean by that is if I have something like x squared minus 16, you should realize that that factor is x plus 4, x minus 4. And then if you're asked to solve, you get solutions of plus or minus 4. You should be able to do a grouping factoring if it has 4 terms. And you should be able to solve with any of the solving techniques we've done, setting it equal to 0 and just adding to each side, to using square roots, or as a last resort using a quadratic formula if you have something that will not factor or solve any other way. So this gives you a good review of the beginning of Chapter 6, which was where we left off before we started getting into the long division and the synthetic division that came next.